Welcome to Grandeur Decoded, where we uncover how the greatest creations on Earth were really built. Today, we are decoding a mansion that looks like a summer fantasy on the cliffs of Rhode Island, but was engineered like a fortress. The Breakers is usually presented as a postcard backdrop for Christmas tours and family photos. The real story is buried underneath. It is one of the most overbuilt private homes of the entire Gilded Age, created for a railroad titan who learned the hard way that technology can turn on its owners. By the end of this video, you will see why the Breakers behaves less like a cottage and more like a private infrastructure project disguised as a coastal palace. Fact 1. The Breakers exist because the first Vanderbilt mansion on this site failed in a spectacular and humiliating way. The original Breakers was a wooden Queen Anne-style residence purchased by Cornelius Vanderbilt II from the Lorillard family. In November of 1892, a fire erupted in the heating system and raced through the floors so quickly that firefighters could do little more than watch it burn. The loss was devastating and publicly embarrassing. The Vanderbilts built their reputation on controlling steam power and running a modern railroad empire. Losing a home to a boiler-linked fire was a symbolic blow. When Vanderbilt hired architect Richard Morris Hunt to design the replacement, he did not ask for charm or whimsy. He gave him one absolute mandate: make it fireproof. Fact 2. The new Breakers was engineered as a steel and masonry strongbox dressed in luxury. Hunt built the mansion between 1893 and 1895 at a cost of more than $7 million, which translates to over $150 million in modern value. Instead of timber framing, he used a skeleton of steel beams cradling shallow brick and tile arches. The structural core contains almost no combustible material. The exterior uses solid Indiana limestone. Roof supports are made of terracotta tile blocks. Floors include brick, cement, and tile. Wood appears only as a surface layer, never as a structural element. If the decorations burned, the house would still stand. That was the point. This mansion was designed from the inside out as a fire-resistant container long before formal fire codes existed. Fact 3. The boilers that power the home were buried far from the living spaces and connected through a hidden tunnel. Most 19th century mansions placed boilers in basements. That is exactly where the first Breakers ignited. Vanderbilt refused to repeat the mistake. The new design placed the main boiler plant underground on the lawn away from the house. A service tunnel of about 350 feet connects the plant to the mansion. Steam and hot water travel through it. Staff could access equipment without entering the house. If a boiler exploded, the blast would be contained under the lawn. It is classic industrial risk engineering. Separate the dangerous force from the asset you want to protect and control it through a single hardened channel. Fact 4. The Great Hall only works because of structural gymnastics usually reserved for stations and early skyscrapers. The 70-foot-high hall appears effortless, but it is supported by steel trusses hidden above the ornate ceiling. These trusses push weight into the outer masonry walls, which are tied back into the cliffside foundations. Without the trusses, the room would need thick columns that would ruin the grand scale. The Vanderbilts wanted a space that felt like European royalty. Hunt gave them something closer to the interior span of a civic landmark. Visitors feel awe, engineers feel tension and respect. This room is not just decoration, it is a demonstration of American steel doing quiet, invisible work. Fact 5. The plumbing system functioned closer to a small hotel than a private home. The Breakers sits on about 13 acres and required substantial water storage to serve dozens of baths, service sinks, guest suites, and kitchen equipment. Period descriptions mention separate cisterns for fresh water and salt water used in certain therapeutic baths. Copper pipes resisted corrosion. Valves allowed staff to isolate sections of the house during maintenance. Water pressure remained stable even during heavy demand. Many American cities at the time struggled to provide consistent water delivery. Inside the Breakers, guests experienced reliable hot and cold water on multiple floors. It was a technological flex that most visitors never realized they were seeing. Fact 6. Electricity inside the Breakers was treated as a potential threat that needed containment. Electric wiring in the 1890s was notorious for starting fires. Insulation was inconsistent and junctions overheated. The Breakers reduced risk by routing wires through ceramic tubes set inside masonry or plaster. High-risk points were kept away from wood. A marble and metal switchboard controlled circuits across the mansion, allowing staff to isolate power in specific wings. As the home transitioned from gas to electric fixtures, the system allowed careful control over load and distribution. Add an Otis elevator and electrically powered service bells, and the mansion begins to resemble a private infrastructure hub, with lighting and communication networks far ahead of most American homes. Fact 7. The cliffside site demanded coastal engineering similar to a fortification. Salt air corrodes metal. Heavy storms drive water directly into stone surfaces. Foundations on coastal sites can weaken if drainage is poor. To prevent this, the breakers was anchored into bedrock using wide footings and reinforced retaining walls. Drainage channels run through the cliff to redirect storm water away from the house. Roof lines move water quickly into stone-lined gutters. Vegetation across the grounds acts as a wind buffer. From a distance, the estate looks effortless. In practice, almost every exterior choice protects the structure from a hostile maritime environment. Fact 8. Almost every room inside the mansion was delivered as a logistics puzzle spanning multiple continents. Interior designers Allard and Sons and Ogden Codman Jr. filled the mansion with imported ceilings, paneling, mosaic floors, marbles, and carved features from Italy, France, Germany, and beyond. Many pieces were fabricated overseas in full-scale sections, labeled, disassembled, shipped by steamship, transported by rail to Newport, and then reassembled inside the mansion. Some rooms include antique architectural elements taken from older European estates. Coordinating this while electricians and plumbers were installing modern systems required precise scheduling. It proved that Vanderbilt wealth could mobilize global supply networks long before such networks were common. Fact 9. Beneath the glamour is a hidden machinery of service corridors, ventilation shafts, and staff circulation routes. The breakers was designed so guests would never see the work required to keep the mansion running. Staff corridors snake behind the walls and under floors. Narrow stairs connect pantries, kitchens, laundry areas, and guest suites without intersecting the grand halls. Dumbwaiters move food and supplies vertically. Ventilation shafts draw heat and odors away from formal spaces. Bell systems allow guests to request service from almost anywhere. A successful evening inside the breakers required dozens of workers moving in synchronized patterns through spaces the public never saw. The illusion of effortless luxury was an engineered performance. Fact 10. The true achievement of the breakers is its transformation of industrial power into the appearance of ease. Add up everything, more than 62,000 square feet of living space, a total building footprint that exceeds 130,000 square feet when accounting for service areas and sublevels, 70 principal rooms, a project cost equivalent to more than 150 million modern dollars, a structural system built of steel, brick, limestone, and terracotta that could survive fires, storms, and decades of salt exposure, boilers hidden in a remote underground plant, cisterns and water networks that rivaled commercial properties, electrical circuits controlled from a central board, elevators, call systems, and hidden corridors. On paper, this is not a home. It is a self-contained infrastructure complex. Once that is visible, the reward becomes obvious. Every chandelier, every mural, every breeze through the Great Hall windows rests on a foundation of extreme engineering that lets the public forget the machinery and see only the magic. If you want more deep dives like this into the world's most spectacular achievements, remember to subscribe. It helps the channel grow, and it tells the algorithm that you want more from Grandeur Decoded.